Welcome back to our channel Active Catalysts. Today I'm not able to record from the gimbal because there is some disturbance in that, like it's not standing, so just with this. Okay, I'm giving my best actually. Please try to hit the like so that it will recommend others also. Thank you. Let us start with the module 2 now. So first question says that prove by mathematical induction. Okay, I'll just tell what you have to do. It's very simple. So to prove mathematical induction, we have two steps, basic step and induction step. In basic step, we have to substitute the value of n to be 1. So when we substitute the value of n to be 1, okay, in this both left and right hand side, we have to substitute the value of n as 1. So once you substitute and solve it, you will get both the sides as 1, which means p of 1 is true. Okay, then we have induction step, means wherever n is there in the question, there we have to substitute as k. Okay, so once you substitute in place of n as k, you will get this equation. Write it as equation 1. Now wherever k is there, we have to substitute the value of k to be k plus 1. In the same question only, you substitute the value of k to be k plus 1. Okay, so once you substitute the value of k to be k plus 1, you will get this kind of equation. Okay, this kind of equation. So again, okay, you will get some value like 2k minus 1 to the whole square when you substitute k as k plus 1. So you already know the answer of 2k minus 1 to the whole square, right? What is that value? This entire part. Now same thing, in place of 2k minus 1 square here, I'll write this value because this is equal to this. So I'll write using 1. I'll write this entire part here. Okay, then see here, this 2k plus 1 square I'm writing as it is. Now in the next step, what we are doing is try to take what is common in all the terms. We can find 2k plus 1 here, right? So I'll take 2k plus 1 common, write this k 2k minus 1 as it is. Then what we have to do is, among this, the square means 2 times it is present, right? Once I will take it out. Okay, so once again, when you remove only once among 2 times, 1 time you have to still write it here, right? So write it here. So then like you cannot do anything here. You cannot apply like a plus b square because this is induction step. In induction step, we cannot use standard formulas actually. We have to prove just by basic maths. Okay, so what I can do is I will multiply this denominator 3 with numerator 3. It will not make any changes to my equation. So once I multiply, see, kindly understand, for every question there is same steps. If you understand this, you can solve any kind of questions from this topic. Okay, so yeah, I'm actually recording from like holding from my left hand. If you are finding it difficult or you understand it, right? So please cooperate. Okay, so what I was telling is, when you're substituting the values using 1, you are adding the denominator part to the numerator also. You are multiplying it. So after multiplying it, you will get something like this. Then what you can do is, see here, minus k plus 6k. You can minus it, right? It becomes 5k. Then what we can do is, this is by 3, right? We'll take it to the another part. Okay, so once you take it, you'll get something like this. Then again, you see if you can take anything common. I think 2k can be taken common. Take it out common, solve it. Very simple, normal maths. Okay, you can just pause for a second and recall what is happening here. Fine, we'll go to the next question now. Okay, second one, they have given a1, a0, a1 and a2 values, and they have given one particular equation to you. We have to prove this. Now in order to prove this, what we have to do is, we have to find the next term of it. Now see here we have an minus 1, write it as it is. An minus 2, write it as it is. An minus 3, write it as it is. Now what we can do is, they have told it can be expressed in the form of 3 to the power of n, right? But here we are finding it for n minus 1. So here also n minus 1. Here it is n minus 2, so n minus 2. N minus 3, n minus 3. So in all patterns, what you can see, it is something like 3 to the power of something. So we are finding it for 3 terms, right? So how it is there, like ak minus 1, ak minus 2. So it is 3 to the power of something 3 times. So 3 into 3 to the power of k. that is nothing but 3 to the power of k plus 1. Okay, so this is true for all the values which is greater than or equal to 1. I hope you have understood. So we'll go to the third question now. Find the number of ways of arrangement of the letter of the word Thalashi, okay, which has no adjacent a's. So in total I have 11 words. They have told no adjacent a's, means 3 times we can see a repeated, right? So 11 minus 3 is 8. We are ignoring 3 a's. How many letters are remaining? 8 letters. Now in this 8 letters only, okay, L is repeated twice, so 8 factorial, total is 8 divided by frequency. L is repeated twice, so 2 times 2 factorial. S is repeated twice, so 2 factorial. E is repeated twice, so 2 factorial. You get this answer. Now you have to draw like 11 blocks because total is 11, right? Now you check like where you can put A in such a way that it is not placed together. All 3 A's are not placed together. When you find the ways, see, if I go on telling the ways and all, it will be too long. So you just pause the video, put 11 blocks and check. Okay. We will find 9 possible ways of placing A. So it is 9C3. Why 3? Because like 3 let A is getting repeated for 3 times. So you'll get 84 as answer. Now we have to find total number of arrangements that is possible. Here we have taken only 8 letters, but in total we had 11, right? So 8 and plus 3, 9, 10, 11. So when you multiply this both, you will get total arrangements. Okay, and most importantly, at the last we have to find in common. What is that common thing is? How many letters are there? 11 factorial. 3 is getting repeated, sorry, A is getting repeated for 3 times, and this L, S, E. Each of the letter is getting repeated for 2 times, right? So whatever is getting repeated for how many times, you have to write down, and later you'll get this answer. Okay, I hope this is clear. We'll go to the next question now. Very simple. We have to use multinomial theorem and find the answer for this expansion. Okay, so it's very simple actually, so please understand this. Okay, whatever power is there, right, you write it in numerator. In below, that is downside, what you have to write is, check how many alphabets we have. How many we have? Like 1, 2, 3. 3 variables. So n1, n2, n3. Then for this equation, okay, for this expansion, write 2x separately, minus y separately, minus z separately. Whatever powers you have here, right? So write it here, n1, n2, n3. Now in place of n1, n2 and n3, we can substitute. What we have to substitute is, see here, x to the power of nothing means 1. So it is 1. Y to the power of nothing means 1. And z is already square. Okay. So when you substitute, what happens now? It will look something like this. See, this is nothing but 4 factorial divided by 1 into 1 into 2 factorial. Okay. So 4 factorial divided by 2 factorial into these 2 and into minus 1. That is minus 24. Okay. Okay, so we'll continue with next part now. 5th question. In how many ways one can distribute 8 identical marbles in 4 distinct containers? So don't get confused. We have only 4 distinct containers. Ignore this diagram, okay? So we have 4 distinct containers and they have told that we have total 8 marbles, okay? So value of R is 8 and containers is 4, right? That is n value. So first we have to find no container is empty. So to find no container is empty, what is the way? We will understand. Okay, so we have standard formula actually. You can find by normal logic also, but without formula for us they don't give marks. So let us solve using formula only. Okay, this is actually first part. Don't assume that this is second. Second one is here actually. Okay, so yes, please understand carefully. It's easy. Only you have to understand carefully. Okay, they have told like n value is 4 and r value is 8, right? This is the formula, that is c n plus r minus 1 and r. So n value we already know, it is 4. Substitute that value. Now for 4th value, why I have substituted 4 here is, in second one we are finding it for 4th container, right? So this question is like, if you understand this answer, you will understand this answer. So I've solved this part now. Okay, so I'm substituting the value 4 because we are finding for 4th container has an odd number. What are the possibility of odd number in 4th container? It can be 1, 3, 5 or 7, right? So accordingly we have to shift. When you compute this, you will get 7, 4, which means 7C4, which is nothing but 35 ways. Okay, so in 35 ways we can arrange. Now what we will do is, see here carefully, it's easy. In fourth container they have told we can place odd numbers between 1 to 8. So it can be anything, right? Like it can be 1, 3, 5 or 7. So in place of R, kindly substitute the value of 7 ones, substitute the value of 5 ones, okay, and substitute the value of 3 ones. So once you substitute every values, we have to add all of them and you'll get one final answer. It's easy. Okay. Then sixth one, in how many ways positive integers n can we form using these digits if we want n to exceed 5 lakh. Okay, so we have 7 digits now. Okay, here we have 7 digits. So using that 7 digits we have to form. They have told it should exceed how many lakh? 5 lakh. So what we'll do is, okay, sorry, I'm telling 5 lakh because we have 7 digits, right? Okay, so they have told that it should exceed 5, it seems. Then it can be 5, 6 and 7, right? So first we will assume that we are taking it as 5. Then what are the possible ways of arranging is, like you may ask why 6 here? Because see, count the number, like 3 is repeated once, 4 is repeated twice, so 1, 2, 3, 4, 5, 6 and 7 is the total number. In total 7 numbers, we are already fixing the first position to be 5. That means how many letters are remaining again? 6, right? Among 7, if you are fixing first position to be 5, how many positions are remaining? 6. So 6 factorial divided by, okay, 3 is getting repeated only once, so 1 factorial, 4 is getting repeated twice, so 2 factorial. Similarly, you check it for all and write this factorial, you will get 360 ways. Now you substitute the value of x to be 6 and then solve. Then 7 you solve. All total you have to add. You will get this answer, simple. Then define well ordering principle. Again we have to solve this using mathematical induction. Well ordering principle is every non-empty subset of positive integers contains smallest element. Okay, this you have to remember. Again, for mathematical induction, it is very simple. Basic step is both the sides, wherever n is there, we have to substitute it to be 1. If you are getting final answer to be 1, then yes, it is true. Then in next step, wherever like n is there, we will substitute k. Okay, then after substituting k, wherever k is there, in that place we will substitute k plus 1. Okay, after you solve, you will get something like this. It's easy. Then prove that every positive integer which is greater than or equal to 24 can be written as sum of 5s or 8s. Okay, this is again using mathematical induction only actually. So like you have to combine 5 and 7. In the final you should get the answer to be 24. What combination we can do? 5, 5, 7, 7. We will get 24, right? Okay, this is the first step. Induction step is very simple. Like we have to combine some 7 values for r times and 5 values for s times. We already know, right? Like how to get 24 using 5 and 7. This is the combination that we can use. But we have to prove it that we can use this combination. Okay, so to prove that, we will consider we are taking 7 for r times and 5 for s times. Now, we should show that s of k plus 1 is true. So to show that, what we are going to do is, now you like observe carefully. We have taken k plus 1, right? So in this step also, in this side, that is right hand side also, you should add plus 1. Then what I'll do is, like here, something like it will be r, like previous of this term is r minus 1, right? So this r minus 1 and this plus 1, one more r, I'll remove it and write it as r minus 2. And whatever 7s were there, how many times did I remove 7? Twice. Okay, so that is by minus 2, so r minus 2. Now this 2 times removed 7, I'll write this side, this plus 1 as it is. Okay, then now we have s. Why we are removing 2 times is, see here, in combination we have 2 times 7, so we are removing 2 times 7. Okay, then we will see this s part now, that is 5. We can just take it 2 times actually, but I'll consider it to be 3, by writing plus 3. Okay, if you take it out, we don't get exact answer. In order to just show that it is the sum of 5s, and 7s we can write it like this. Okay, if you take it out also you'll get same combination only. This much if you do you'll get full marks. I've written this answer according to scheme of evaluation. Okay, then similarly one more question we have, like we have to prove it using mathematical induction. I hope this is very clear to you. First, what is the basic step? Wherever n is there we will substitute 1. Next, wherever n is there we will substitute k. Then wherever k is there we will substitute k plus 1. Simple, right? I hope I shouldn't be explaining it again. Okay, next one. Find number of permutations of letter of word, this word. In how many of these all 4 A's are together? How many of them begin with S? Okay. So in this kind of questions, first find total number of letters, that is 10. In that, I think 1, 2, 3, 4. 4 times A is getting repeated and S is getting repeated for 3 times. So write it as it is, you will get one answer. Then consider 4 A's together as 1 unit. Whatever is getting repeated, right? So we'll consider that to be 1 unit. Then remaining 6 letters we will consider as 6 units. So 1 plus 6 is 7 units. Divided by 3. Why divided by 3 is letter S is getting repeated 3 times. So 3. We will get answer to be 840. You can say now letter S is getting repeated 3 times. Why can't I consider that to be 1 unit? No. Like frequency, you cannot consider it to be 1 unit. Okay. Now they have told second condition, how many of them begin with S? So if it begins with S, first alphabet is fixed as S, right? Now how many letters is remaining? In total is 10. First letter we will fix as S. Remaining 9 alphabets. In remaining 9 alphabets, S is again repeated twice. A is getting repeated 4 times. So find this, you will get this answer. Okay, total is 9 divided by S is repeating twice and A is getting repeated 4 times. Then, okay, one more important kind of question again. This is again multinomial only. Whatever is given in the question, write it in this form. Like what is the power of expansion? You will write it here. N1, N2, because only we have 2 terms. Then 2A minus 3B. Then this powers we will write N1 and N2 as it is. Like N1 is 1 actually. I think this question is solved wrong here. N1 will be 5 and N2 will be 2. Okay, please make the correction. Like same question was repeated where here it was AB square. Okay, that is the mistake. This 5 was like here it should be 5. Okay, please make the changes and solve accordingly. Then by using binomial theorem, we have to prove that this is present in this term. What is binomial theorem? This is the like expression for binomial theorem. So we have something like x to the power of something and y to the power of something. Now, like how do we choose the value of r is? Okay, how do we understand the value of r is? When this equation you write, right? Okay, you already know the value of n. N means this power, 7. By putting what value of r, you will get total answer to be 7. That is what you have to check. By putting the value of r as 5, we will get this value. Okay, so we'll substitute the r value as 5. Once you solve this, you will get this equation and that is the answer. For this simple question, you'll get 7 marks. Then one more mathematical induction. I think you can solve it. Okay, I'll just skip it. Simple, because you already know what it is. Then next one, very simple one. We have this word called as statistics. Okay, in statistics we have total 10 letters where 3 is like T is getting repeated, I is getting repeated, and I think one more word, I think S is getting repeated. So whatever is getting repeated, write it here and find the factorial first. Okay, for this only you'll get 2 marks. Then in how many ways of these A and C are adjacent? So we have to keep A and C as adjacent, right? So it can be AC or CA. So we'll consider that to be 1 unit. Okay, when you consider this entire part to be 1 unit, again except A and C, S is also getting repeated thrice, even 3 thrice. One is I is getting repeated twice, and AC we are considering that to be 1 unit, which is getting repeated as once. So total we have 9 factorials. Okay, 9 factorial. Why 9 factorial? Because they have told in how many ways of these A's and C are adjacent. First only we'll consider, we are taking that as the unit. Okay, so then when you solve, you will get this answer. Y into 2 is, it can be AC or CA, right? So into 2. Okay, now second question is, in how many vowels are together. So first of all, what are the vowels present here in the question that we will see. Okay, I think A and I is getting repeated twice, so we'll consider that to be 3 vowels. See, whatever is getting repeated twice and all, right, repeated, that you cannot consider as one unit. Okay, now find the factorial again. Now you may ask, why 3 factorial divided by 2 factorial? Very simple, like A is getting repeated thrice, right? I mean 3 times in the word statistics. So it is like 3 factorial divided by 2 factorial. So I'll get this answer. I think I told A is getting repeated twice. No, it is not A actually. I think the letter that is getting repeated thrice is T. Okay, it is T. Then we'll go to 14th question. Find coefficient. Same thing. This is what now? Binomial theorem. So if they ask, find coefficient of one term in some expansion, this is the formula. Now in order to find the value of R, this is the standard formula. Just put the value of 11. N value you already know it is 11. Check what value you can put for R so that both sides it will be equal. So once you find the value of R, okay, R we got as 3. Substitute everywhere the value of R, then you'll get one final answer. Simple. If you do, you'll get 6 marks. Then obtain recursive definition. Again, it is very simple. They have given a few like equation form. I'll give 2 examples. This first 2 I will solve. Next 2 you have to solve. So concentrate here. An is equal to 5n is the question. First time what I will do, in place of n I'll substitute 1. When I substitute 1 I'll get only 5. Similarly, in place of n I'll substitute n minus 1. So when I substitute n minus 1, something this I'll get. Now to obtain recursive definition, we have to subtract an minus 1. So when you subtract that, you'll get this value. Okay, we'll get a1 as 5, which is greater than or equal to 2. Why greater than or equal to 2 is they have given in the question. Okay, I've written half question here actually. They have told find whether it is greater than or equal to 2. Similarly, solve for these questions also. Then we have 16th question where they have told a woman has 11 close relatives and she wishes to invite 5 of them to dinner. So 11 divided by 5 and remaining is 6, right? So into 6 we get it as 46. That is only first answer. If there is no restriction means common part to solve. Then second one, 2 persons will not attend separately. So 2 persons means like total, like she can invite only 5 of them. Among 5 they have told 2 of them will not attend separately, 3 is remaining. So 3 more relatives are remaining. So 9C3. Okay, I hope you get it. Now why 9 is 11 minus 2 is 9. So 9C3. Now we will add both the answers, because if 2 are not invited, then 5 relatives will be there from 9. So 9C5. So once when we add this part, you'll get this answer. So like add it up, or you can leave it like this only. Then third part of the question is 2 persons will not attend together. They have told among 5 relatives, either first 2 or next 2 or last 2 will not attend together. It can be in any order. So like that we will get how many times? 4 times. So it can be 9, 5, 9, 4 or 9, 4. Any of this order is okay. So 9C5, 9C4, 9C4. When you add all this, you'll get 378. Then in how many ways can we distribute 7 apples? And see, remember, whenever in question they say in how many ways, then we have to use this formula. Here they have not given in how many ways. Only in the starting if they give in how many ways, then use this formula. In middle and all if they give, no. Okay. So when you substitute these values, you will get this answer. It's simple again. Everything is given in the question only, values. I hope you will understand. And the next important question that we have to prove is, like they'll give one series which is Fibonacci. We have to tell that yes, it is Fibonacci series. In order to prove this, again, it's very simple. We have to prove by mathematical induction. I have not done completely. You already know what is basic step, induction step. So try to compute it. It's very simple. Try it by yourself. Definitely you'll get correct answer if you have understood the first question what I have explained. Okay, then 19th one. How many arrangements are there for all letters in the word sociological? Okay, first we will find normal one, like total letters 12. Whatever is getting repeated, you write it here and you'll get one answer. First they have told AG is getting R adjacent. We'll consider that to be 1 unit. Okay, so among 12, like 2 letters are already here. Then how many letters are remaining? 10 letters, right? So we'll consider that to be 10 units. So among like total is 11. Why into 2 is because it can be AG or GA, two combinations. So 2 into 11 factorial. Why 11? Among 12, 1 unit is already removed. Okay, so that is why here. Divided by whatever letter is getting repeated here, right? So that, right? Find the answer. Simple, right? Then all vowels are adjacent. Now take vowels to be adjacent. Like I is getting repeated twice, O and A is getting repeated once. So whatever is getting repeated once, you write it in denominator. Total is 6 factorial. Why 6 is we have total letter like alphabets, right? So check how many slots are left out. You will get 6. Later you can solve. Why 6 have explained here. You can pause and check. Okay, then one more kind of question, that is multinomial theorem, which we have already solved. Whatever is the value of n that we will write here, then how many alphabets we have? 1 2 3 4 5. So 1 2 3 4 5. Solve it for all the values, you will get the simple answer. Then we have find number of permutations of letter word engineering. I hope you can solve it now. Okay, whatever is getting repeated, all e's are together. If they use the word repeated, you cannot consider it as one unit. They just told us all e's are together. That means you can consider it as one unit. For every question it's same. Okay, whatever is getting repeated twice, thrice and all, you can consider that to be one unit and solve it. It's easy. Okay, it's very easy. That is why most of them told me that do second module, which is easy. Okay, so that's it for the second module. I have got only 21 questions from second module. I hope you have understood. Sorry for the camera facilities and all. I'll try to give my best for the second video. Like I don't have the proper one. Let's see how it goes. If you'll continuously support me like this, I'll definitely buy a good mic and good camera also. And heartfully thanking each one of you for making this family of 1K subscribers. Thanking you from the heart. We'll meet in the next video. I'll share the small notes in the community post. You have to just click on that pic to like view the complete image. Okay, you can definitely view the complete image, and if I get 200 plus likes, then I'll upload this in the form of PDF. Okay, I'm doing this because only having the target that this video should be reaching to everyone who is struggling in discrete mathematics. I know you are also like somewhere stuck. Definitely will help everyone and move together. Like if you walk alone, you will walk and stop at one particular distance. But if we all walk together, definitely we will reach our success point. We'll meet in the next video.